Hello kids, in this video I am going to talk about combination of resistors. Children, we already have the formula for resistors in series as Rs is equal to R1 plus R2 plus R3, which says when several resistors are joined in series, the resistance of the combination Rs equals the sum of their individual resistances R1, R2 and R3 and is greater than any individual resistance. Similarly, for resistors in parallel, we have 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we get the answer as the reciprocal of the equivalent resistance is equal to the sum of the reciprocals of the individual resistance. Now children, let us try using these two formulas for combination of resistors. Now we have to solve the equivalent resistance for this given circuit if the value of R1 is 5, R2 is 10 and R3 is 20 ohm. Now before solving the question, we have to first be clear how are the resistors connected here. R1, R2 and R3 are connected in series in this particular circuit. We can make out that they are in series connection because the same amount of current I is flowing through R1, R2 and R3. So we will use the formula for resistors in series. Now before solving the question, let us first write down the values given to us. R1 5 ohm, R2 10 ohm and R3 20 ohm. We will write a statement that R1, R2 and R3 are in series. Therefore we will use the formula Rs is equal to R1 plus R2 plus R3. Putting the values of R1, R2 and R3 as 5, 10 and 20 respectively, we get the answer Rs is equal to 35 ohm. So for this particular circuit, the equivalent resistance is 35 ohm. Similarly, let us solve another question. In this figure, the resistors are in parallel connection. How can we make out that they are in parallel connection? Because this current I is getting distributed into R1, R2 and R3. So to solve the equivalent resistance of this circuit, we will use the formula for parallel connection. So we will again write a statement R1, R2 and R3 are in parallel connection. Therefore 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is a simple mathematical formula. I would suggest that children keep on writing the LHS continuously as 1 by Rp, putting the values of R1, R2 and R3 as 5, 10, 20 respectively and solving this equation. We get the answer as 1 by Rp is equal to 7 by 20. But we want the answer as Rp, not 1 by Rp. So we will convert Rp is equal to 20 by 7, which is equal to 2.85 ohm. Children, this is a common mistake done by students that they get the answer directly from this particular step as 1 by Rp is equal to 7 by 20 and then immediately children write Rp is equal to 7 by 20. But please note that the answer is here is 1 by Rp is equal to 7 by 20, but you have to take the value as 1 by, not 1 by Rp, but Rp is equal to, take the reciprocal of the value you have got here. Now let us do another question, which is the combination of both series and parallel connection. And the question is, calculate the equivalent resistance and the total current flowing in the given circuit. Now the question is, which formula are we going to apply here, the series connection formula or for the parallel connection? Now if you see this figure very carefully, then there are two sets, two combinations are here. Here R1 and R2 are in parallel connection because the current is getting distributed here. And similarly 3, 4 and 5 are also in parallel connection, but all 5 of them are not at a time in parallel connection to one another. We can imagine this R1 and R2 as a, if we imagine this R1 and R2 as a single resistor and this 3 and 4 and 5 as another resistor, then we will see that this combination is in series connection with this combination. Yes, we will first use the formula for parallel connection for R12, and then we will use the same formula for R345. So we'll get the answer for this combination and this combination. So then at last we will apply the formula of series connection for this combination and this combination. Why they are in series? Because the current that is passing through this combination, the same current is also passing through this combination. Children, let us do this and be clear with how to solve this question. The values of R1, R2, R3, R4 and R5 are given. We will solve this combination first, this part of the circuit first, and we will write R1 and R2 are in parallel connection. But instead of using the symbol as RP, because 2 times we have to use the formula for parallel connection, so for our convenience we will use 1 by R12 is equal to 1 by R1 plus 1 by R2. Putting the values of R1 and R2 as 10 and 40 from the figure, we get the answer as 1 by R12 is equal to 1 by 8. So R12 is equal to 8 ohm. Similarly, for the next set, we will use the same formula and give a statement R3, R4 and R5 are in parallel connection. Therefore, 1 by R45 is equal to 1 by R1 plus 1 by R4 plus 1 by R5. Now putting the values 30, 20 and 60 for R3, R4 and R5 respectively, we get 1 by R45 as 1 by 10. So R45 is 10 ohm. Now we have got the values for R12 as 8 ohm and R45 as 10 ohm. So just imagine this is a single resistor and this is again a single resistor. So these two resistors are in series. So we have to use the formula for series. So I can say R12 as a single resistor and R345 as a single resistor are in series. So RS is equal to R12 plus R45. So putting the value of R12 as 8 ohm and 10 ohm for R45, we get resistance as 18 ohm for the entire circuit. So the equivalent resistance for the entire combination is 18 ohm. Now coming to the second part of the question, where we have to find the current. The potential difference is 12 volt from this figure and the resistance we have just found out as 18 ohm. We have to find the current. We will use the formula for of Ohm's law for solving this question as V is equal to IR, but since we have to find out I, so we will write the equation as the other way. IR is equal to V, so I is equal to V upon R. Putting the values of V as 12 and R as 18, we get the value of I as 0.67 ampere. So this is how, children, we solve such questions.